Good evening, everyone, and welcome to my live stream. So, today we are going to cover the topic of lowest common multiple or LCM. In yesterday's live stream, we discussed about HCF or the highest common factor. So, you may consider this as a continuation from yesterday's live stream. And in case you missed my live stream, the video has been saved in my YouTube channel. You can visit my channel and you may refer to the live videos section, so where the video has been uploaded, so you can go and refer to that video. Okay, so you might be listening some noises from background, so there is a little bit of celebration going outside my residence, so I will just request you to ignore the noises. Anyways, so let us begin. So it is very suggestive of the topic lowest common multiple. Now let us first discuss what a multiple is. A multiple is obtained by multiplying any number with natural numbers. So this is very simple. Like if I am to find out the multiples of 5, multiples of 5. So basically we are referring to the multiplication table of 5, right? So 5 into 5 is 5 into 1 is 5, 5 into 2 is 10, 5 into 3 is 15, 5 into 4 is 20, and so on. Okay, if I am to write multiples of 11, I am just randomly picking up numbers. Okay, so multiples of 11 can be 11, 22, 33, 44, 55, and so on. Okay, so this is how we write multiples. So just before beginning, a quick note, just keep in mind that factors of a number are limited. So we have limited factors, is it? If I ask what are the factors of 5, so 1 and 5. In fact, 5 is a prime number. In fact, both 5 and 11 are prime numbers. Okay, so factors of a number are limited, but multiples can be unlimited. That is the reason I have given some dot. So these dots mean continuation. Okay, multiples of a number are unlimited. So just a small bit of information before starting. So let us discuss the first method of finding the lowest common multiple. This is the prime factorization method. Same way, like if you remember from yesterday's stream, so we will follow exactly the same step. Okay. So let me write the heading: prime factorization method. So in case you have forgotten what prime factorization is, we have to keep on dividing a number by prime numbers. That is what prime factorization is. Okay, let me just underline it. Find the LCM of 40, 36 and 126 by prime factorization method. I hope my handwriting is understandable. Okay, so we'll start by the prime factorization of 40. So what is the smallest prime number? Smallest prime number is 2. So we'll divide 40 by 2. 40 divided by 2 is how much? 20. Then what is 20 divided by 2? 20 divided by 2 is 10. What is 10 divided by 2? 5. Okay, and 5 is a prime number, so 5 is divided by 5. So we will keep it in this way. Next we have 36. 36 is divisible by 2. So 36 divided by 2 is 18. Excuse me. Then 18. 18 divided by 2 is 9, and 9 is divisible. In fact, 9 is not divisible by 2, so we have to divide it by the next prime number, which is 3. Okay. And last, 126. So 126 divided by 2 is 63. Now 63 is not divisible by 2 because the number ends with 3. So we have to divide it by 3. 21. We can divide it by 3 again, and then 7. Okay. So we'll write 40 equals to 2 into 2 into 2 into 5. Then we have 36. 36 is 2 into 2 into 3 into 3, and 126. 126 is 2 into 3 into 3 into 7. Okay. Now, so we will follow the same method like we followed in HCF. So what we'll do first, we will list out all the common factors that we have in all the three terms. Okay, so we can write 2. 2 is a common factor in for 2 is a common factor among 40, 36 and 126. Okay, then is there any other number which is common in both the not both common in all the three terms? No, so we have only 3. So let me write LCM of 40, 36, 126. So first up we will write that number which is common in the three terms. Okay, so 2 is a number which is common in all the three numbers, common for all the three numbers. Next we will find out those numbers which are common between any two numbers. So we can see that this 2, among 40 and 36, we can see that we have a pair of 2. So we'll write that particular 2. Okay, then among 36 and 126, we can see that we have 2 pairs of 3 which can be written as common. So for this particular pair, we will write 1 3 and another 3. Okay, then finally we will write all the numbers which were not common among the three numbers. So we have 2, a 5 and a 7. 2, 5 and a 7. Okay, so we'll multiply all the numbers and then we'll get the LCM of 40, 36 and 126. Okay, so let me do it in a rough part. So we have 2 into 2 into 2. So 2 into 2 into 2 is 8. Then we have of 5. 8 into 5 is how much? 8 into 5 is 40. Okay, then we have 9. 3 into 3 is 9. 9 into 7 is 63. Okay, so our LCM is 2520. So this is how we do LCM. We find out LCM for 3 or more numbers using prime factorization method. Okay, so you can take a screenshot of this if you want. हेलो आयुष, क्या हाल चाल है आपके? Okay, so we'll continue with one more question. So we'll find out the LCM of 84, 90 and 120. Okay, so we'll start off with the prime factorization of 84. So 84 is divisible by 2. Okay, so 84 divided by 2 is how much? 42. 42 is again divisible by 2, so this is 21. So 21 is no longer divisible by 2, so we'll have to divide it by 3. So 3 and 7. Fine. Then 90. So we'll divide 90 by 2. 90 divided by 2 is 45. So 45 is not divisible. 45 is not divisible by. So 45 divided by 3 is 15. Then we have to divide it by 3, and 15 divided by 3 is 5. Okay. And last 120. Okay, 30 divided by 2 is 15, and 3 and 5. Okay, so 84. 84 is 2 into 3 into 7. Then we have 90. So 2 into 3 into 3 into 5. And then 120. 120 is 2 into 2 into 2 into 3 into 5. So let me write LCM of 84, 90, 120. So what we'll have to do? We'll have to list all the factors which are found common for 84, 90 and 120. Like if you look at this 2 is common in 84, 90 as well as 120. So for this 2. Okay. Then anything else? Yes. This 3 is common in 84, 90 as well as 120. So I will write 3. Okay. And then there is no other number which is found common in all the 3 numbers. So then we'll have to check. Okay, so this 2 and 2 are found common in 84 and 120. So for this particular 2 we will write 2. And in the same way this 5, we have a 5 as a common factor in 90 and 120. So 5. So whatever number remains we will write. So we have this 2 and 3 and 7. So 2 into 3 into 7. So if we multiply these numbers, we will get our LCM. So 5 into 2 is 10, 3 into 3 is 9, and 2 into 2 is 4, 9 into 4 is 36 into 7. Okay, so it is just a coincidence that the LCM of the previous question was also 2520. Okay, so for both the questions we did today we got the same answer. Okay, so this prime factorization is easy to understand, but it is lengthier when we compare. Okay, so we'll learn the next method. So this is known as common division method. So just like in ACF we learned continued division, so here in the LCM part we have common division method. So let me write the heading. I will show this with the same set of example. Okay, common division method. So while I am preparing this, may I request my viewers to please like my stream. Your one like is equal to or equivalent to one encouragement. Common division. Okay, so these methods are very suggestive of their names. No? Common division, that means we have to divide all the 3 numbers at the same time. Okay, this is actually, you can say, an advanced form of prime factorization where we will do this 3 prime factorizations together at a time. Okay, Let's see. I'm not writing the question because these are the same numbers. So how we'll write? We'll write 84, 90 and 120. Okay. And then we'll divide. Okay, divide by the smallest prime number. So 84 divided by 2 is 42. 90 divided by 2 is 45. 120 divided by 2 is 60. So this method takes a lot less time when we compare it with this one, prime factorization. Okay. Now again divided by 2. So 42 is divisible by 2. So we'll write 21. Now 45 cannot be divided by 2. So we'll write 45 as it is. Okay. And then 30. So as long as there is one number which can be divided by 2, we will keep on dividing. And we'll keep the other numbers waiting. 21 cannot be divided by 2. Neither can 45. So we'll just divide it. Divide the 30 by 15. Divide 30 by 2 and we'll get 15. Okay. Now 21, 45 and 15. These are not divisible by 2. So now we'll pick the 4. We'll pick the 3, which is the next prime number. So 21 divided by 3 is 7. 45 divided by 3 is 15 and 15 divided by 3 is 5. So we'll pick a 3 because we have still 15 which can be divided by 3. So 7 cannot be divided, so I will write it as it is. Then 15 divided by 3 is 5 and then 5. Okay. Now these three numbers cannot be divided by 3, so we'll pick the next prime number which is 5. So we'll keep 7 as it is because 7 cannot be divided, and 1 and 1. Okay. And lastly we'll write 7. So whenever the last three numbers or whatever, in this case we had three numbers, so I am saying 3. So when all the numbers are 1, our division process is finished. Okay. So we'll simply multiply the factors and then we'll get the LCM. I hope this part is visible. Yes, this is visible. LCM of 84, 90 and 120. So we'll multiply all the numbers. 2 into 2 into 2 into 3 into 3 into 5 into 7, which gives us 2520. Okay. So like I said, this method takes a lot less time when we compare it with prime factorization method. I beg your pardon. So if you want, you may take a screenshot. So we'll move, or should we take one more example? Let us do one more example and then we'll discuss one more topic related to both HCF and LCM. Okay, so I'm moving to the next part. So while I prepare, may I request my viewers to like my stream. When you like a stream, it gets recommended to more and more people, which in turn gives me a lot of encouragement. Okay, so don't just watch, like the video, share the stream with your friends, and if you are new, please subscribe to the channel as well. I will take 4 numbers now. Okay, find the LCM of, let me write the question, find the LCM $75, $250, $225, common division method. Okay, so one common mistake I have seen made by students whenever they see such numbers, right? Their tendency is to just jump and divide the numbers by 5. Okay, technically that is correct, but if we have to follow the rules, I mean, very bookish way, if I have to say, we always have to start by the smallest prime number. Like, yes, all the four numbers are divisible by 5, but we have 250. 250 is divisible by 2. So we have to divide it by 2. We don't have any other option. Okay. I have seen, I mean, teachers deducting marks for not doing it this way. So it is just a word of caution. Otherwise, technically, there is nothing wrong if we divide it by 5. But don't divide by composite numbers. Don't divide it by 10. Then it will be wrong because 10 is, I mean, you can divide it by prime numbers taken in any order, but don't just divide by composite numbers. Okay, so we'll divide it by 2. 75 remains unchanged. This is 125, and these numbers will remain unchanged. Okay, now none of the numbers are divisible by 2. Okay, so what we can do, we can pick the next prime number, which is 3. Now I told you how to check whether the numbers are divisible by 3 or not. What we have to do, we have to add the numbers. I mean, add the digits, sorry, not the numbers. Add the digits. If the digits, sum of the digits is divisible by 3, then the number itself is divisible by 3. Like 75. 7 plus 5 is how much? 7 plus 5 is 12. 12 is divisible by 2. Sorry, divisible by 3. 125. 125 is not divisible by 3 because 5 plus 2 is 7. 7 plus 1 is 8. Then 225. 225 is divisible because 5 plus 2 is 7. 7 plus 2 is 9. And similarly 5 plus 5 is 10 and 10 plus 2 is 12. So except 125, all the three numbers can be divided by 3. So I will divide it by 3. So 75 divided by 3 is 25. 125 will remain unchanged. This will be 75, and this will be how much? 3 into 1 is 3. 3 into 7 and 5. Okay. So again, 75 is divisible by 3. So I will divide it by 3 first. 25 remains unchanged. 125 will remain unchanged. 75 divided by 3 is 25, and 175 will also remain unchanged. Now we can divide the numbers by 5. 25 divided by 5 is 5. 125 divided by 5 is 25. 25 divided by 5 is 5. And 175 divided by 5 is how much? 5 into 3 and 5, 35. So we'll keep dividing by 5. 5. 5 into 1 is 5. 5 into 5 is 25. 5 into 1 is 5. 5 into 7 is 35. So 2 more steps. 1. 5 divided by 5 is 1. 1 and 7. And lastly, we will divide it by 7. Okay. So our division part is over. Now we'll multiply all the factors and we'll get the LCM of these four numbers. So while I am multiplying, so I am requesting my viewers to like my stream. And if you are new to my channel, welcome very much. And you may subscribe to my channel. Two into three into three into five into five into five into seven. So, so this is a rough calculation, okay? So our LCM is 15,750. Okay, so you can find out LCM of any given numbers. We have taken four numbers. You can find the LCM of 5, 6, whatever the number. I mean, you won't get such big question, but this method can be used to find LCM for any set of numbers. Okay. So I hope the process of finding out LCM was clear. And for ACF, you can just go to my channel and check the videos which are uploaded in the live stream. HCF was covered in yesterday's live stream. So ACF and LCM. Now we are going to discuss one more topic, which is the relationship between the ACF and LCM of two given numbers. So let me just write the heading and adjust my notebook as well. So just a reminder, I have written two numbers. So this relationship can be used only for two numbers, not more than that. Suppose we have two numbers, A and B. Okay, so what does the relationship say? The relationship says that the LCM of AB and the ACF of AB when multiplied, that means the product of the ACF and LCM is equal to the product of two numbers. Okay, so if I am to write this in a statement form, I will write LCM into ACF equal to product of two numbers. Excuse me. So this is the relationship. When we are given two numbers, the ACF of that number multiplied to the LCM of two numbers is equal to the product of those numbers. So this is a very important relationship. Okay. So let's solve some questions based on this particular relationship. Okay. So I'm just turning to a new page. So I am using a book which is meant for class 6. Okay, because these topics are first taught in 6th standard, but application continues throughout your academic career. Okay, let me just write the question. I hope my handwriting is understandable on the camera. The LCM and ACF, that means the lowest common multiple and the highest common factor of two numbers, are 180 and 6 respectively. If one of the numbers is 30, if one of the numbers is 30, find the other number. Okay, so we have been told that the ACF and the LCM of two numbers are 6 and 180 respectively, and one of the number is 30 and we have to find the other number. Okay, so we are going to use the relationship between ACF and LCM. I will just write the relationship in the rough part. So what was our relationship? ACF into LCM equal to product of two numbers. Okay. So we'll write. So what we can do, we can assume that the required number is, say, any variable x, y, z, a, b, c, d, whatever. So let the required number be a. Let me assume it to be a. So we have ACF into LCM or LCM into ACF, whatever, whichever way you want to write. But make sure if you are writing ACF, then write the correct figure for that. Okay. Otherwise, your marks will be deducted in the exam. The product of two numbers. So ACF is 6, LCM is 180, and product, the one of the number is 30 and the other number is A, so we'll write 30 into A. Okay, so what we have to do, we have to transpose this 30 to the right hand side of the equation. So I would suggest no need to go for the multiplication, so just keep it 60 into 180 and then divide it by 30. So this 0 and 0 gets cancelled, and you can divide 18 by 3 or you can divide 6 by 3. Both numbers are divisible. So let me divide the 6. So 6 divided by 3 is 2 and 1. So 36. So that means the required number is 36. So this is how we use the relationship of ACF and LCM. Okay. Let me try a few more questions. So sometimes we may be asked to find out the LCM and ACF, not both the LCM and ACF in the same question, either the LCM or ACF. In that case, we will be provided with both the numbers. I mean, if you have noticed, we have four, what should I say, four variables. No? We have ACF and LCM and two numbers. So out of these four, any three will be given. Otherwise, it is not possible to do. Okay, so let me write down one more question. So while I am picking the question, may I request my viewers to like my stream, and if you are new, please subscribe to the channel. Okay. So the question says that the ACF of two numbers is 16 and their product is 3072. So like I said, we have been given three values here. Three in a sense, we have been given the product. The product of the numbers is 372. Their ACF is 16 and we are required to find the LCM. Okay, so we are going to use the same relation. ACF into LCM equals to product of two numbers. Whenever we are solving a question in the form of an equation, we have to always use the imply sign. Okay, that is one thing you should keep in mind. Don't use equal sign, because you cannot use two equal signs in one particular expression. So ACF is 16 and we don't know what the LCM is, and the product is 3072. So for finding the LCM, we are going to transpose the 16 to the RHS, right hand side. So as we have multiplied 16 with the LCM, so when we transpose it, we will do the opposite of multiplication. We will divide 372 by 16. Okay, so let us do a rough calculation. So 16. And therefore the LCM is 192. Okay, so this is our answer. Fine. My voice is cracking down a bit, so I beg your pardon for that, because I have been taking continuous classes throughout the day. Some physical classes, some online classes. So this is the last session of my day. Fine, so we will do one more question and then we will end today's live stream. The ACF of two numbers is 145 and their LCM is 2175. If one number is 725, find the other. So we have been told that the ACF of two numbers is 145. The LCM of those two numbers is 2175 and one of the numbers is 725. So we are going to find the other number. So like just like the previous question, we can assume let the other number, or you may write let the required number, let the other number be A. So the relationship is HCF into LCM equal to product of two numbers. So what is our ACF? Our ACF is how much? 145 and the LCM is 2175. So product of two numbers. So one of the numbers is how much? 725 and the second number is, we have assumed the number to be A. So again I would suggest don't go for multiplication, otherwise this will take unnecessary time. Okay, we will just keep it as 145 into 2175 and then we will transpose the 725. So we can find the common factor and then we can start the cancellation process. So quite obvious, we can divide it by 5. So 5 into 2 is 10, 5 into 9 is 45, 5 into 1 is 5, 5 into 4 is 20 and 5 into 5 is 25. So let me check, 29 into 5. 29, we can divide 145 by 29. 5. So the remaining 5, let us use it to divide 2175. So we have got 435. And therefore the other number or the required number, whichever way you want to write, the other number is 435. Okay, so this type of questions can be expected in exams, so this is a very important topic. So this sums up our live stream on ACF of LCM. ACF we covered in yesterday's stream, and in today's stream we covered LCM and the relationship between ACF and LCM. Let me just check the time. Okay, it's almost 11:50. Fine, so we'll end today's stream here. So I come live every day. I have been doing live streams continuously without a break. So tomorrow let us find some new topic and let me see what can be done. Anyways, so thank you to all my viewers for coming live and liking my stream, supporting me through this 1 hour. It's already very late and that too on a Sunday night. So I really appreciate all my viewers for coming live and encouraging me. So thank you so much for coming. Like my stream. You may visit my channel and check out my shorts, my long format videos. You can subscribe, you can share it with your friends. Do whatever you can do to support me and my channel. So thank you so much for coming. Bye bye and good night.